Welcome back to our channel Chemistry Land. In the previous video, we have seen the first three types of classifications of polymers. In the present video, today we will see about the last three types of classifications of polymers. Let us see. Classification of polymers. So the last three types of classifications. So fourth classification is based on structure. So based on the structure of the polymers, polymers are classified as linear polymer, branched polymer and cross-linked polymer. So what is meant by linear polymer? If the monomeric units are linearly arranged in the polymer chain, that is called as linear polymer. The name is linear homopolymer. Homo means same, that is same type of monomers are arranged in the polymer chain. So it is called as linear homopolymer. Next example is linear copolymer. It is otherwise called as linear heteropolymer. That is different types of monomeric units are arranged in the polymer chain. So it is called as linear heteropolymer or linear copolymer. So this is the first type. The second type is branched polymer. What is meant by branched polymer? That is, if the monomeric units are arranged in branched function, that types of polymers are called as branched polymer. See the example, branched homopolymer, branched copolymer. Here in branched homopolymer, the same monomeric units are arranged in branched function. So it is called as branched homopolymer. So in this example, different types of monomeric units are arranged in branched function, that is X, Y, X, Y. So different types of monomers. Two monomers are arranged. So it is called as branched copolymer or branched heteropolymer. This is the second classification. Third one is cross-linked polymer. If the monomeric units are arranged in cross-linked function, that type of polymers are called as cross-linked polymer. For example, cross-linked homoform. See the example is, the same type of monomeric units are arranged in crossed function. So that point it undergoes cross-linked. So this is cross-linked homoform. So based on this structure, polymers are classified as linear, branched and cross-linked polymer. The next classification is based on tacticity. So what is meant by tacticity? That is geometrical arrangement of characteristic groups of monomers are arranged with respect to the main polymer chain. Characteristic groups or functional groups of monomers are arranged with respect to the main polymer chain. So it is classified as three types. It is divided into three types, that is isotactic polymer, symbiotic polymer, atactic polymer. So first one, isotactic polymer. Here we take the example, that is polypropylene. So propylene is the single monomer. It polymerizes to give long polypropylene chain. The characteristic group of the monomer is methyl group. See the example, it is a long polymer chain, polypropylene chain. The methyl groups are arranged, the characteristic groups are arranged on the same side of the polymer chain, polypropylene chain. So if the monomers are arranged on same side of the polymer chain, that polymer is isotactic polymer. Second one is symbiotic polymer. The characteristic groups are arranged on alternate of the polymer chain, that is with respect to the polymer main chain, the functional groups, that is methyl groups of the monomer, are arranged in alternate function. So one up and down, up and down. So that type of polymer is symbiotic polymer. Next one is atactic polymer. Here this is the polypropylene chain. Here the characteristic groups, that is methyl group of the monomers, are arranged in random function. Random means orderless. So if the monomeric units are arranged in random function with respect to the long polymer chain, that type of polymers are called as atactic polymer. So based on tacticity, the classified as isotactic, symbiotic and atactic polymer. Last classification is based on use and applications of polymers. There are many applications of polymers and uses. They are classified as plastics, elastomers and fibers. So plastics are organic materials of very high molecular weight. They can be molded into any desired shape by the application of heat and pressure in the presence of a catalyst. So plastics They have many uses in day-to-day life. For example, polyethylene, PVC pipes we know, polyvinyl chloride. So based on the applications of polymers, it is classified as plastics. The next one is elastomers. Elastomers have good strength and high elongation. So the best example is natural rubber, butyl rubber. So these are elastomers. Last classification is fibers. So fiber is a thin thread-like structure of a natural or artificial substance. It may be natural or artificial substance. It is used to make the cloth, robes, etc. fibers. So it is classified as natural and synthetic fibers. So examples for natural fibers are wood, silk, cotton. So these are the natural fibers that is directly extracted from plants and animals. Next one is synthetic fibers. So the example for synthetic fibers is sterling. Okay. So based on use and applications, the polymers are classified as plastics, elastomers and fibers. So these are all the last three classifications of polymers. So totally 6 types of classifications of polymers we have seen it. So all of you support this video. Please subscribe our YouTube channel Chemistryy and press the bell icon, like it, share it and comment it. Watch the full video. Thank you.